In this video, we are going to begin the creation of our scene editor. The purpose of the scene editor is to allow us to create and manipulate node networks using the mouse and keyboard. So more technically, its purpose is to take the input given by the user and translate into something that will usefully manipulate the scene. Now we're going to create the scene editor as its own class, so that way we can encapsulate everything that it does into one convenient class, keeping the scene class a bit cleaner. Now inside of the scene editor, there are a few key concepts it will be containing. It will be based in state, keyboard input, and mouse input. In state, we're going to have a scenario where we're allowed to select whether we are in move mode or in select mode, so that the editor will be able to work on existing nodes without the danger of moving them. And we're also going to be using the mouse input and keyboard input classes that we assembled in earlier videos. So really we're going to be bringing everything together inside of the scene editor itself. So to get started, let's move up to the editor folder and add in our new class. This is going to be the scene editor. And inside of our new scene editor class, we'll begin by cleaning up our namespace, removing the .editor sub namespace. Now we need to add in some using statements, so I'm going to get slightly lazy and steal some using statements from the mouse input class. This will give us the using statements for framework and framework.input. Now the scene editor is going to need to be able to draw some information to the screen, so I'm going to add an additional using statement for framework.graphics. Alright, now as we move into the editor itself, we need to be able to remember the editor's own state. That is, we need to be in select mode or in move mode. We need to be able to tell the difference between the two. So to store this information, we're going to create an enumeration called edit mode. So I'll make an enum called edit mode, and we will place two elements into this enumeration. We'll have select and move. Now inside of the scene editor itself, we'll begin working on the class by creating an edit mode field. So we'll have a field that will allow us to store our current editing state. So we'll make an edit mode field called edit mode. And again, this will allow us to tell whether we should or should not be moving items. Now, moving on into our methods, the first method we want to address is actually the constructor for the scene editor itself. So we'll drop in a public constructor. So we'll say public scene editor, and it is inside of this constructor that we need to initialize our input handling. Basically, we need to be alerted when various mouse and keyboard events occur, so we will utilize our keyboard input and mouse input classes. Now, we're going to get into the mouse input when we actually establish the concept of selections, but here with our edit mode check, we can set up some keys that will let us switch back and forth between select and move, and that'll give us a chance to try out our keyboard input and our event handling here in the scene editor. Now, before we fire off any keyboard events, we need to make sure that we tell the keyboard what keys to be looking out for. So let's set up a scenario where we have the Q key bound to select mode and the W key bound to move mode, which means the first thing we need to do is make keyboard input aware of both of those keys. So, looking here at keyboard input, we will invoke the add key method, and we will pass in the value of keys.q, and we will do the same line. Matter of fact, I'll just duplicate this line, so we can call the add keys method for the key W. So again, this will make us aware of both keys. Now we're ready to subscribe to the event. So we'll take our keyboard input, and we will say keyboard input dot keypress plus equals, and this gives us the hint of a possible name for our new handler. So I'll hit tab to drop in the new key handler delegate, and tab again to create the handler method for that delegate. And I will take out the exception indicating that it has not yet been implemented. So here we have subscribed to the key press event. So inside of this event handler is where we're actually going to be looking for Q or W to be pressed. So we'll begin an if statement saying if key. Again, this key is coming in from our key handler delegate. So we have the current key and then all of the keys that are part of that state. So if the current key is equal to keys dot Q, then we need to enter select mode. So we will say this dot edit mode becomes equal to edit mode dot select. Now if the W key was pressed, we need to do the same code, except that we will set ourselves to the move mode. So I'll duplicate the if statement, but I will change the second if statement to an else if to make it a clause to our overall if statement. So we will say else if keys equals keys.w, then our edit mode needs to be set to edit mode.move. So with this in place, we should have the ability to switch back and forth between modes. But in order to see that reflected without having a scene in place, we're going to create a display that will tell us our current mode, which will still be useful when we have a scene, because then we can see at a glance why we can move or can't move actors. So let's put together a draw method, and then inside of that draw method, we'll issue what the current mode is. So we'll make a public void method called draw, and we will take in a sprite batch, which we will simply call sprite batch. Then inside of this method, we will use that sprite batch to draw the current mode to the screen. So using sprite batch, we will call drawString. And to draw a string, we need to pass in first a font. We'll get the font from style dot, let's take font large for our font. Next, we need the string that will be displayed, and we will use some string formatting. Now, to make it a little bit easier to read on our limited recording area, I'm actually going to define the text externally as a local variable. So I want to make a string variable called text, and that will be equal to string.format, so that we can actually say that this is mode and then whatever the mode happens to be. So we can say mode : and then specify in brackets, we can say argument 0, then feed that argument to string.format, and here we'll just feed in this dot edit mode. And that takes care of the call to string.format, and that takes care of assembling the text variable. Now back in drawString, we can put text in place as the text to be drawn. Then we can move on to the position for the text, and I'm simply going to give a 10 pixel by 10 pixel offset from the top left of the screen. To do this, I'll drop in a new vector 2 with values 10 and 10 in x and y. Finally, we have the color of the text to be drawn, and I want to draw this as color.white. Alright, that takes care of our text drawing. And at this point, if we were to build the project, we can see that scene editor gets saved out, and we're not seeing any syntax errors. So let's test out the new editor. In order to test it, we need to get this, we need to get an instance of the scene editor set up in the actual scene. So back here in scene navigation, let's establish a new field. Let's make a field of type scene editor, and we'll just call this field scene editor. Then inside of the build scene method, we will actually instantiate the scene editor. So scene editor will be equal to a new scene editor. And finally, in the draw method, we'll make sure that the scene editor gets drawn. So right after we get past our actor drawing loop, we'll make a call to the instance of scene editor and call upon draw, where we will need to feed in the current sprite batch. Alright, now we should see some result when we launch this, but we will need to address a few more things to make it usable. So, launching the game, we can see that we have our current mode as select. If we hit the W or Q keys, we see that we get no effect whatsoever. This is because we are currently relying on keyboard input. Looking at scene editor, of course, we're relying on this event to get fired to know that something happened. And we are not yet passing any form of update calls to keyboard or to mouse input. because, of course, both of these classes are dependent on calls to their update method. So at this point, in order to get the input system fully functional, here inside of scene navigation, we need to make sure that we issue out calls to keyboard input dot update and mouse input dot update. And just one quick note about the order of these. I'm issuing keyboard input first, so that any calls to is key down will be using the most up-to-date, basically up-to-date as of the overall update to the entire scene. Now again, this is generally not that important, because even if we used last key, that would be at most one update behind. But again, since we want to be able to sample keys at random, I am making sure that that gets called first. Now with both of these getting called, let's test out our editor. If we hit the W key, we can see that our mode changed over to move. So using Q and W will let us switch back and forth very quickly. So we do have the base of our scene editor working, and we can tell that our keyboard input system is also working. Now there's one last thing I want to do inside of scene editor. This idea of adding and binding keys is done for the sake of efficiency, and generally in a game you would want to keep things as efficient as you could. But in our case with an editor, it gets inconvenient as you're making different modes and different respected keys, because you can very quickly forget to add a key, especially since there's no official binding system, as in there's not a config file that contains all of these keys. So for the sake of keeping the editor simplistic, we're actually going to tell the keyboard input to be aware of every possible key. Of course, this does make the code a little bit more inefficient, because if we were to jump very briefly into the definition of the keys enumeration, we can see that there are many keys. But again, in this case, we're going to do a trade-off for simplicity for the sake of readability. So what we're going to do, instead of adding the keys one by one, is we will assemble a simple loop that will let us walk through all of the keys in the keys enumeration and tell the keyboard input to watch for all of them. The way we'll do this is the enum type has a getValues method that'll let us gain access to all of the elements inside of keys, and we can store those in an array. So that means we need to begin with a keys array, and we'll create that here. So here we are inside of the scene editor's constructor. We'll make a keys local variable called allKeys. And we'll set allKeys to be equal to enum.getValues. Now getValues is going to need to take in the type of the enumeration of interest, so we need to issue the typeOf command. So we'll grab typeOf and then pass in keys for the keys enumeration. Then we can close off the parenthesis to the call to getValues. Now getValues is going to return an array. So basically it's just looking at objects. We need to cast this into the specific array that we're using. So we are going to cast the result of this as a keys array. So once we issue this line, we should have the allKeys array populated by all of the elements available in the keys enumeration. So with this array, we can now loop over it and add all of them to the keyboard input. So let's begin a for each loop. So we'll say for each key in all keys. We'll take that key and we'll add it to keyboard input. So we'll say keyboard input dot add key, passing in the current key. As a matter of fact, I'm going to take the braces out of the for each loop since it's only a single line, and I'm also going to remove the lines where we were adding by hand the Q and W keys. So now if we were to build and run, we could see that W and Q are still working just fine. Now to point out the overhead that this introduces, let me actually set a breakpoint right before we get into the for each here. And we can see that right before we enter the loop, all keys currently contains 160 elements. So there's actually 160 different keys that are contained in that enumeration. I'll hit Shift F5 and jump out of the debug session and point out that this means that since inside of the bound keys loop we do 2 checks, that means we're performing 320 individual checks. And that's per state, and then multiply that by 2 because we have 2 states, and you can see that a lot of actual checks are being done. But again, in this case, It makes things very easy to read because we issued this once, and now our keyboard input system is aware of all possible keys. Now, in the context of a game, you would definitely want to bind individual keys, or even look at some of the alternate methods of getting key input from the actual X and A keyboard input state. But in our case, in order to put everything together and have all keys available, this makes a quick and easy way to accomplish that. So, now having established the scene editor class and having fully linked up all of our input systems, we now have the base of the scene editor ready to go. We have its basic draw functionality, and we have noted how input handling is going to work here inside of the scene editor. So with that, that's going to wrap up this video.